use Kirchhoff's rules to examine the following circuit. So we have two batteries now. There's one. We're connecting through one resistor up here. Another battery. Another battery. Looks like that. And then another resistor down on the bottom. We're going to call this one R1. 3 ohms. Our resistor on the bottom is R2 at 2 ohms resistance. Our first battery is putting out 150 volts. And our second battery is putting out 50 volts. And for this particular problem, you're told that the potential at this location, which is P, the potential is 130 volts. And we are asked to find the potential up here at a location called Q. So what is V at Q? Now, the potential is the same throughout this wire. So anywhere from here, so this kind of portion that I'm highlighting or thickening here, all that is 130 volts. But as soon as I skip over or pass over this resistor and then through this battery, I'm going to change my potential, and same goes with here. So if I travel up through the battery and then through the resistor, I can go either way to get to Q. But what we're going to do is use Kirchhoff's rules. And so the first thing we can compute our loop. And for the example that I laid out for you, we started our loop at P, and we're going to go this way. We're going to do a complete loop through the circuit, and that's going to be loop 1. And let's also guess that the current, typically what I like to do is go to the larger battery, in this case the 150 volt battery, the more powerful battery. And we're going to assume that our current I is flowing out of that battery. So I goes this way, and then goes up and around, and then back down into the battery. So our loop is clockwise, our current is counterclockwise. And let's start applying Kirchhoff's rules. So the first thing we're going to do, starting at P, we are crossing R2 in the opposite direction of I. And so that's going to give me a plus I times R2. We are crossing the battery in the sort of opposite direction from positive to negative, and so it's going to give us a minus E1. All right, minus because we're crossing from positive to negative. If we go from negative to positive, then we add the battery. Up top, the current is flowing from right to left, but we are passing through the loop from left to right, and so that's going to give me a plus I times R1. And then finally my loop passes the battery here from negative to positive, and so that's going to give me a plus E2 is equal to 0 volts. And so let's solve this for I, because what it's going to allow us to do is then compute the actual drops across the either resistor, depending on whichever way we end up going here. So let's solve this for the current, which is the only unknown in this problem. So that's R2 plus R1. And over here, we're going to have an E1 minus E2. I'm going to bring terms together. And that's going to be 150 volts minus 50 volts, or 100 volts. And so the current then, and you can see here too, where these things, they are in series with one another, and so they add together. 2 ohms plus 3 ohms is the same as I times 5 ohms, which is equal to 100 volts. So then I, our current, is 100 volts divided by 5 ohms, or 20 amps. Sweet. So now we know our current. So now let's apply that, and we can actually, again, check ourselves. It's always good to check yourselves with these types of problems. So we're going to go from P to Q, and we have two ways to do that, but now we know our current is 20 amps. And so I'm going to clear the screen here. And again, let's just sketch out our battery so we have it, or our circuit. It doesn't take that long to redraw this one. And this was 3 ohms, 2 ohms, and 50 volts, and 50 volts. And we know that I is 20 amps. Incidentally, because we got a positive current, we know that the current has to be flowing in that direction. And we're going to go from here, which is 130 volts, and figure out the potential up here. All right, so if we go this way, in the same direction as the current, we're going to start at 130 volts. We're moving through a 50 volt battery from positive to negative, so we get a negative there. And we are going to cross this 3 ohm resistor up top in the same direction as the current. And so that's going to give us an I minus I times 3 ohms. So that's 130 volts minus 50 volts minus 20 times 3, 60 volts. So this is 130 volts minus 110 volts, which is 20 volts. Not 120, 20 volts. Okay, and again, we can check by going in this direction. And so if we start at P, which we have to, and go in the opposite direction of the current now, we're going to get a plus I times 2 ohms. And we are going to subtract 150 volts. And that's going to give us our potential at Q. So that's 130 volts plus 20 times 2, or 40 volts, minus 150 volts, which is 170 volts minus 150. And sure enough, we got 20 volts.